Electrochemistry is based on oxidation-reduction reactions. In this video, we will learn how to identify redox reactions. This video is followed by another video that shows how to balance redox reactions. Before you watch this video, I would recommend that you first watch my video on how to assign oxidation numbers or states to different elements within a compound, as it will provide you with the relevant background. So, for the first step for identifying a redox reaction is to calculate the oxidation number of the main elements involved. In this reaction, copper and zinc are the main elements that are involved. Sulfate just acts as a spectator ion. It doesn't do anything, it just remains there, sits there in the solution. So, what's the oxidation number of copper here? We will calculate this one together. So we don't know its oxidation number, it's X. We know that the oxidation number of sulfur in sulfate is 6. In this compound, there are 4 oxygens present, so 4, and the oxidation number of oxygen is -2. So 4 times -2. From that previous video, we know that the sum of the oxidation numbers of all the elements that are present within a neutral compound is equal to 0. So now we have an equation and we can isolate X. So X would equal 4 times 2 is -8. It goes to the other side, it becomes 8. 6 is positive, it goes to the other side, it becomes negative. So X is equal to 8 minus 6, which is 2. So 2 is the oxidation number of copper before the reaction. After the reaction, when copper is in its elementary form, it's not combined with any other atoms, its oxidation number is 0, according to the first rule in the previous video. Similarly, the oxidation number of zinc before the reaction takes place is 0. And after the reaction, the oxidation number of zinc is +2. And you can calculate this in the same way we calculated the oxidation number for copper. So, how do we identify a redox reaction? A redox reaction involves an exchange in the electrons, and we can identify it by calculating or tracking the change in the oxidation numbers of the main elements involved. Now this reaction, does it involve a change in the oxidation numbers? Let's see, the oxidation number of copper before the reaction is 2, and after the reaction it decreases to 0. The oxidation number of zinc before the reaction is 0, and after the reaction it changes to +2. Because there is a change in the oxidation number of the main elements involved, this is a redox reaction. Now, the redox reaction is divided into 2 parts. There is a reduction half reaction and there is an oxidation half reaction. Reduction is the gain of electrons, and this half reaction is identified by a decrease in oxidation number. As there is a decrease in the oxidation number of copper, it decreases from 2 to 0. This represents the reduction half reaction. So we can write, before the reaction we have the copper ion which has a 2+ charge, and after the reaction its oxidation number decreases to 0 as copper is present in its solid form. Now as reduction is the gain of electrons, we have to include these electrons in the equation, and because electrons are gained, they are written on the left hand side of the equation. So we write the electrons here as they are gained. Now we need to balance this equation, balance the charge on the left hand side of the equation. If the total positive charge is 2, then the total negative charge also has to be 2. So we need to have 2 electrons on this side of the equation. Now moving on to oxidation. Oxidation is the loss of electrons. So in an oxidation equation, the electrons are added to the right hand side of the equation because it involves a loss of the electrons. So, and it is identified by an increase in the oxidation number. So the oxidation number of zinc increases from 0 to 2. So this is where this represents the oxidation half reaction. So to start with, we have zinc in its solid form, and after the reaction, the oxidation number of zinc has changed to +2 as it's present as a monatomic ion, and the charge on a monatomic ion includes its oxidation number. And as this is an oxidation reaction, there is an increase in the oxidation number. We lose electrons. Electrons are written on the right-hand side of the equation. And we need to balance out the charge on this side of the equation. There are 2 positive charges, so we need to add in 2 electrons. So now we will learn about the identification of oxidizing and reducing agents. So copper is where the reduction takes place. We can also say that copper is the oxidizing agent. It is where the reduction takes place, so it is involved in oxidizing. And zinc is where the oxidation takes place. Zinc loses electrons, so copper can have it. So this is the reducing agent. Zinc loses electron, so copper has it. Zinc oxidizes itself to reduce copper. So zinc is the reducing agent. So this is how we can identify redox reactions by calculating the changes in the oxidation numbers of the main elements involved. And by the gain of electrons and a decrease of oxidation number, we can identify reduction half reactions, and oxidation half reactions can be identified by a loss of electrons and increase in oxidation number. The element which represents the reduction half reaction is the oxidizing agent, and the element which represents the oxidation half reaction is the reducing agent. I hope this helped you. Please watch the video on how to balance redox reactions to learn that. Thank you.